Good morning. This is your Stat Sensei, Mr. Spensei, and this is our uh, test review on two sample T, and this is going to be a two sample T interval, and it's adult playtime. A sociologist is investigating whether, oh, and excuse me, let me back up. What they're going to want us to do is they're going to want us to create a 95% confidence interval for the difference in recreation time for the two age groups. Okay, so let's read our scenario. It's adult playtime. The sociologist is investigating whether older adults engage in more or fewer recreational activities than younger adults. The study specifically focused on individuals between the ages of 18 and 25 and 55 to 65. So we have two different populations. One's 18 to 25, the younger group, and then we have an older group of 55 to 65. While younger adults are often seen as more active due to their higher energy levels, older adults may compensate by participating in slower paced activities such as gardening, knitting, or walking. A random sample, okay, so random sample of 50 young adults and 50 older adults was selected. So we got two random samples, all right? We have two populations, two random samples, one of 50, so N1 is 50, and N2 is 50 was selected for the study. Data was collected on the average number of hours spent per week on recreational activities. The researcher is concerned with whether there is a significant difference between the two groups in terms of the total number of hours spent weekly. The population of young adults and older adults are destined to be 15 million young adults. Okay, there's our pop for young, the big population, and 25 million older adults. All right, so there is our other population. All right, so we're looking to run this test, and we got this information from them. So they're telling us they have 7.6 average hours a week for young adults and 8.3 hours a week for the older adults. These are our sample standard deviations. They both have sample sizes of 50, so N1 is 50 and N2 is 50. And they told us this population, the younger adult population, was 15 million, and the older adult population was 25 million. All right. So we're creating a 95% confidence interval. So here's our formula. Sample mean of 1 minus a sample mean of 2 plus or minus T star. Standard deviation of the first squared divided by its sample size. Standard deviation of the second group squared divided by its sample size. So we've divided up our groups into young adults and older adults. And young adults have a sample mean of 7.6, 3.1, and a sample size of 50. Older adults, 8.3, 3.8, and a sample size of 50. We already have all that. We know that we're doing a 95% confidence interval. So this is what we're looking for. And we know the sample mean. Now, if we're working with a hypothesis test, we're centered on the population mean. Hypothesis will be mu1 minus mu2, but we're working with the confidence interval, so it's x1 minus x2. Well, 7.6 minus 8.3, 7.6 minus 8.3 is negative 0.7. So the center of my sample is at negative 0.7, and I'll need a lower bound and an upper bound when I run this test. And at this point, I know it seems a little bit weird, but we're going to go ahead and run this test so that we can get our degrees of freedom to calculate our T star. So, stat test. Oops. Stat test. And we're going to drop all the way down to number 0, where it says two sample T interval. And X bar 1 is 7.6. Standard deviation is 3.1. Sample size is 50. X bar 2, 8.3. Standard deviation is 3.8 for the older adults, and we have a sample size of older adults of 50% or 50, and we want a 95% confidence interval, and we never pool in this course. So we end up getting negative 2.077 and 6.77 is our lower and upper bound. But what we need right now is our degrees of freedom. And our degrees of freedom are approximately 94.20. All right. So we have everything to plug into our formula except for T star. All right. And we need the degrees of freedom to calculate T star because we have X bar 1, etc. So to calculate T star, we're going to go second vars, inverse T, at parenthesis 1 minus the 0.95 divided by 2. And degrees of freedom were what we got from the test, which is 94.2. And by the way, we're really fortunate to have the calculator because that's a really ugly formula to use. And we end up getting 1.9854. So, and this would be the way we show our work. Inverse T, 1 minus 0.95 divided by 2. That's parts and parentheses. Let me check that real quickly. That test 0. Yeah, 94.20. So this should be a 94.2005. And when we did our second vars, inverse T, 1.985. Okay. All right. Now we have a different number on the end. I get a 4, here's a 1. But we have 7.6 minus 8.3. That's plugging in. Here's our T star. Then we have a 3.1 squared over 50, a 3.8 squared over 50. And we know we're running a 2-sample T interval for means. All right. And that's what the calculator told us. We went stat test. We dropped down to 0. And it said 2-sample T interval. So there we go. All right, we have to define our parameter, and our parameter is let mu is true population mean recreation for young adults. All right, true population mean hours for young adults. And for the mu2s, let mu2 equal true population mean recreation hours for older adults. So our conditions, well, we have 2 independent random samples of size 50. All right, these two always go together. So if you don't have to separate them as 2 separate numbers, but 2 independent random samples of 50, and this is given. We have 50 times 10 is 500. That's less than 15 million. And 50 times 10 is 500, and that's less than 25 million. So we need to add the little phrase down at the bottom that says both samples are less than 10% of the population. Yay, that's good. And both samples are greater than 30, so they're both normal by central limit theorem. So both samples are normal by central limit theorem. All right, conclusion. We are 95% confident the true population difference of the means. Real important we have this. And where this comes from, difference of the means, there's a mean and there's a mean, and we subtracted. And the word subtract, another word for subtract is difference. So that's the difference of the means. Now that's the difference of the sample, but we're actually estimating the difference. We're estimating mu1 minus mu2. So this is what we're estimating. Although this is our sample, and that's what we did, we're using that to estimate the difference in a population mean. Difference of the means, weekly recreation time hours for young adults minus the weekly hours for older adults. And this basically came from our parameter right here. Please make sure you have the word minus. And we know that that difference lies within our interval 2.077 or negative 2.077, 2.677. And that's what we calculated when we ran our test. And then finally, in repeated sampling, we expect this method to capture the true population difference of the means, which we talked about a moment ago. We got that from the formula where once again had the x1 minus x2 so that we could estimate mu1 minus mu2. That's what we're estimating. We know that. That's what we use. That's the difference of the means. Weekly recreation hours for young adults minus the weekly recreation hours for older adults, 95% of the time. All righty. Appreciate you watching. I sure hope that helps. Thank you.